Hello again, everybody. This is Mr. Hoy. In this example, we'll be looking to find the value for x given the shape, a rectangle, given the area of that rectangle, in this case being 12, and given that the sides are measuring different polynomials. So one side is x, the other side is 2x plus 5. I took the liberty of drawing a rectangle, and I've placed those side measures here and here. It doesn't matter if you have them here and here, or you have that reversed. But I would strongly recommend drawing a quick diagram when you're doing these questions, just so you can visualize what we're talking about, especially at the end of the question when we go to look for extraneous answers. Having this visual is definitely helpful. Alright, so got an area formula here for the rectangle. Area equals length times width. I'm going to replace the area with 12 because we know the area is 12. And I'm going to replace the length with x and the width with 2x plus 5. What we're going to do then is we're going to distribute the x. We're going to get area, or in this case 12, equals 2x squared plus 5x. At that point, we want to subtract 12 from both sides. We will get 0 equals 2x squared plus 5x minus 12. I'm subtracting the 12 here because I'm looking to apply the zero product property, as we have in the last couple of weeks, in solving this equation. So we get down here, we want to factor this using the AC method. When looking at this problem, AC is 2 times negative 12. So we can say that that is negative 24, and we're looking for factors of negative 24 that add up to positive 5. The factors in that case are going to be negative 3 and positive 8. Generally, a good idea is to put the negative number first, so I'm going to write that negative 3x here, positive 8x there, and go back to just leaving the 2x squared here in the lead and the minus 12 there at the end. So then we want to factor by grouping. We factor these two, factor out an x, we're left with 2x minus 3. We can factor out a 4, we are again left with 2x minus 3. We would then have 0 equals 2x minus 3 times x plus 4. Alright, now we're going to solve these two expressions as equations. So we're going to set the 2x minus 3 itself equal to 0. And I'm going to also set the x plus 4. Let me see if I can find a marker that writes. I will set the x plus 4 equal to 0 as well. Subtract 4 from both sides here, and we will get x equals negative 4. With the pink equation, we have one more step than that. We're going to add 3 to both sides, get 2x equals 3, then divide off the 2, and get x equals 1.5. You could write this as 3 halves, you could write this as 1.5, or 1.5. Any of those will work. Now, I mentioned before the importance of the diagram. This is where that comes in. You definitely want to have the diagram because you can take these values that you have down here and substitute them to see which one works, which one doesn't work. I'm going to start with this one here. It's probably the easiest to substitute because if you put negative 4 in as a side measure, so let's say we remove the x temporarily, we put negative 4 there, that's not possible. You cannot have a side measure to any shape that is negative. So right away what we can do is we can look at this term, and we're going to refer to this as an extraneous solution. So it is an answer that we solved for, we did all the math correctly, but in terms of practicality, in terms of actually applying to geometry, we can't make that work. There's no side measure of negative 4, so this one we're just going to go ahead and exclude from the question. Now we can take the 1.5 and do the same test there. We can try 1.5 here. A side measure could certainly be 1.5, and we could plug the same 1.5 here. So 2 times 1.5 would be 3. 3 plus 5 would give us 8, and a side measure can certainly be 8. Now we just want to check to see if the area works out. 8 times 1.5 does get us back to 12, so we go ahead and verify that answer, and the x equals 1.5 for this question.